One way to rank the risks of a project or an organization is through the linear correlation tornado graph. In IziRisk, it is possible to visualize such a tornado after running a simulation. For example, of the 69 types of risks managed at this financial institution, 22 of them have been escalated as quantitative risks. For each one of them, we have defined the annual frequency of the event and its severity or impact. If there is enough historical event data for a type of risk, IziRisk automatically calculates the parameters to build the frequency and severity probability distributions. Otherwise, an expert can always add their best judgment by suggesting the average annual frequency and the minimum, the most likely, and maximum parameters for each one of the risks. IziRisk will simulate 100,000 different scenarios, adding all the quantitative risks. These are summarized in a histogram from which the operational value at risk of all risks can be obtained. In this example, the average loss due to operational risks is $11.7 million, while its value at risk at 95% reaches $12.9 million. To rank the risks, we can use a tornado graph that calculates the linear correlation coefficient between each of the individual risks and the total aggregation of them. In this example, the correlation coefficient between counterfeit risk and total risk is the largest of all, topping the top of the tornado at 0.83 coefficient. In other words, of all the quantifiable risks, counterfeiting is the one with the highest correlation coefficient versus the total risk. If we displayed the thousands of scenarios generating between the risk of counterfeiting and the total risks in a scatter plot, we can see how these thousands of scenarios line up. We could say that the correlation coefficient is a relative measure of how far away all these points are from the best fitted straight line. The closer this coefficient approaches 1, the closer all these points will be with respect to the relationship line of the one variable with respect to the other. That is, the stronger its correlation index will be. If the values of one variable change systematically with respect to the values of another, it is said that both variables are correlated. In this sense, as the coefficient approaches 1, we can affirm that there's a relatively high degree of variation in the total risks when the risks of counterfeiting tend to be high and vice versa. On the contrary, when displaying the correlation coefficient between the risk modeling errors and total risks, we observe that this index is only 0.11. That is, it is a relatively low correlation coefficient. This implies that regardless of what happens in the risk of modeling error with high or low scenarios, the total risk is not going to be impacted in the same direction in a significant way. In this way, by consolidating the correlation indices between each of the risks and the total aggregate risk, we were able to obtain a relative measure of the importance of each risk when it comes to impacting all of them. These coefficients cannot and should not be added in their interpretation, but they do give us a first approximation, much better than the chromatic classification, to the relative importance of each one of the risks, determining the aggregation of them all.